Alright, so on number 1, on this you're supposed to find the sine, cosine, tangent, cosecant, secant, and cotangent of the triangle here on the left. In order to do that, the first thing you need to do is you need to use Pythagoras' theorem to figure out the hypotenuse. So Pythagoras' theorem says a squared plus b squared equals c squared. So you do that and you grab your calculator. So go to your calculator. So you have 8 squared plus 15 squared. Enter. Now you take the square root of that answer to see if it comes out evenly. If not, you'll have to do a little factor tree. Square root of 289 is 17. So it came out evenly, so you know that x is 17. So now, make sure you go from the angle, which is in the bottom right-hand corner. So from this angle, these are the two sides that form the angle. It's not a real good color. So these are the two sides that form the angle, two legs. So this is the opposite side, and this is the adjacent. This is the hypotenuse. It's important that you get the opposite and adjacent correct, or else you'll miss 4 of the 6 of these problems. Well, you miss all of them. So opposite is 8 over 17. Cosine, adjacent over hypotenuse. So that's 15 over 17. Tangent, opposite over adjacent. So opposite over adjacent. Now the cosecant, you just reciprocate these. So that's 17 over 8. Secant, that's the reciprocal of cosine. So 17 over 15. And cotangent is 15 over 8. So that's number 1. Number 2, given a point on the terminal edge of an angle, find all 6 trig functions. The point is negative 3, 7, so I graphed it. I went over 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, put my dot, and I connected that dot to the origin. Now what I'm going to do is create a triangle from that. And we always draw our angle down to the x-axis. So I come down to the x-axis, and now I have a triangle. Our reference angle is always the angle inside the triangle, right at the origin. So with that being set up, this is negative 3, because it's 3 over, and it's 7 high, so this is 7. So now we need to find the hypotenuse. Again, we'll use Pythagoras' theorem. Negative 3 squared plus 7 squared. So that's 9. 3 times 3 is 9. 7 times 7 is 49. So we get the square root of 58. Because, remember, this is what c squared equals. And so to get rid of a squared, we square root it. So we have the square root of 58. Now that does not come out to be an even number. So I'm going to break it down. So 58 is divisible by 2 because it ends in an 8, which is an even number. And 58 divided by 2 is 29. 29 is prime, so there's not a pair of numbers to come out of the square root. So I'm going to leave this as the square root of 58. So now I will label the sides of my triangle. Again, we're going from that reference angle, which is the angle right here at the origin. This is the opposite, this is the adjacent, and this is the hypotenuse. So sine of theta is opposite over hypotenuse, so opposite over hypotenuse. So 7 over the square root of 58. We don't like to leave a square root on the bottom, so we multiply top and bottom by the square root of 58. So we get 7 square roots of 58. That's the top multiplied by it. When I multiply the bottom by a square root of 58, the square root of 58 times the square root of 58 is just 58. That's why we multiply it by the square root of 58, is because 2 square roots of the same number multiplied together gets rid of the square root. and it's just 58. The cosine is adjacent over hypotenuse, so that's negative 3 over the square root of 58. So again, I don't like to leave a square root on the bottom, so I multiply top and bottom by the square root of 58. So that's the top multiplied by the square root of 58, and the bottom multiplied by the square root of 58 is just 58. Tangent is opposite over adjacent, so opposite over adjacent. Now I'm going to flip these upside down to get the cosecant, and I'm going to use the first part, not the second part, just because I don't want to. If I flip the second part, it puts the square root back on the bottom, whereas if I flip the first part, it's just the square root of 58 over 7. Same with this. This is the square root of 58 over negative 3, and this is negative 3 over 7. And that's my answer. That's all you have to do on that. So that's my answer for sine, my answer for cosine, tangent, cotangent, secant, and cosecant. Number 3, convert the angles in radians to degrees and the degrees to radians. So, to convert from degrees to radians, you times it by pi and divide it by 180. So now you can do that on your calculator if you want. We're not going to actually times it by pi, we're going to leave it there. We're just going to go 200 divided by 180. Then I go math, enter, enter, and it's 10/9. You can do that without a calculator. Zeros go away. 20 and 18 are each divisible by 2. 20 divided by 2 is 10. 18 divided by 2 is 9. Or you can use your calculator. So it's 10 pi ninths. So 200 degrees is 10 pi ninths. Excuse me. To convert from radians to degrees, you times by 180 and divide it by pi. So our pi's cross cancel. So our pi's go away. And we have 7 times 180 divided by 4. 180 divided by 4 is 45. So 7 times 45 is 315. We could also use our calculator and just go 7 times 180, because that was the top part. So see, the top part was 7 and 180, the pi's went away, and then we'll divide that by 4. Divided by 4. And that gives me 315 degrees. So to convert 150 degrees, I times it by pi, divide it by 180. Each of these, 15 and 18, are each divisible by 3. So I can get rid of the zeros, divide those by 3, and I get 5 pi. 18 divided by 3 is 6. Or again, you can use your calculator. 150 divided by 180. Math. Enter, enter. 5/6. 11 pi 6, again, to convert from radians to degrees, you times by 180, divide it by pi. Your pi's cancel. And we have 11 times 180 divided by 6. So 11 times 180 divided by 6. And it's 330. You could have also just looked at your unit circle on these last two and found the corresponding parts on your unit circle. Number 4, draw an angle for each given angle in standard position. That should say standard position, not form. All right, so negative pi fourths, positive angles go this way. So they go counterclockwise, but negative angles go clockwise. So negative pi fourths is 45 degrees, so I come 45 degrees downwards. It's right here. I draw this little line showing I've gone downwards. This is my angle of negative pi fourths. 195 degrees. All the way to here is 180. So if I've gone 180, that leaves me 15 degrees. So 15 degrees more. There's 195. These aren't exact, these are just rough estimates. Negative 200. So I've gone negative 90, negative 180. So if I go 180 from that, that leaves me with 20 still. So I go 20 degrees more, and that's right there. 3 pi fourths, that's 135 degrees. Or you can think of it this way, there's 1 pi fourths, 2 pi fourths, 3 pi fourths. Because so each of them is a fourth of the halfway there. So 1, 2, 3 pi fourths. That's all you have to do on that one, is draw those pictures. Number 5, find the coterminal angle. So the easiest way to find the coterminal angle is add 360 to the negative number. So negative 100 plus 360 is 260 degrees. What that means, here's your picture. Negative 100 is right here. If I go positive 260, there's 180, and 80 more makes 260, I get a complete circle. What it means is I've got two angles that have both finished at this same point. The yellow one and the blue one have finished right here. That's what coterminal means. So the easy way is just to add 360. You could have also subtracted 360, and that would have given you negative 460. That would have ended at the same place as well. So I told you to add 360 if it's in radians. The same as 360 is 2 pi. That's 360. So that would be, if I get common denominators, I multiply this by 3 on the bottom, multiply it by 3 on the top. 3 times 2 is 6. So 2 pi plus 6 pi is 8 pi thirds. You can also do this by subtracting 2 pi. So you can either add or subtract 2 pi. So I'm going to subtract 2 pi. Again, if I get common denominators, multiply that by 3, multiply the top by 3, that becomes 6. 2 minus 6 is negative 4. So negative 4 pi thirds. So either of those answers would work. 210, if I add 360, that would be 570 degrees. And you could keep adding 360 or keep subtracting 360 as many times as you wanted. They would all be coterminal, because they would just keep going round and round and end up at the same place. I could also subtract 360 from this. So 210 minus 360 is negative 150. On the last one, again, I'm going to add 360, which is 2 pi. If I get common denominators, I multiply the bottom by 12, multiply the top by 12. 12 times 2 is 24. So 24 minus 5 is 19 pi twelfths. You could also subtract by the same amount. Negative 5 minus 24 is negative 29 pi twelfths. So to find the coterminal, just add 360 or minus 360. And that'll give you an angle that is coterminal with the given angle. Number 6, what is the reference angle? So the reference angle is the angle that goes back to the x-axis. So if I go negative 100 degrees, that's right there. So the reference angle, if I draw this back to the x-axis, is the angle that's formed at the origin, and it's right here. So a straight line has 180 degrees, and I've used 100 of it. So if I go 180 minus the 100, that gives me 80 degrees left in here. So my reference angle is 80 degrees. 2 pi thirds, that's right here. So my reference angle formed, if I draw this back to the x-axis, is this angle inside of here. So 180 degrees is the same as pi. So I'm going to go pi minus 2 pi thirds, because that's going to tell me how much this piece is. So to get common denominators, I multiply the bottom by 3, multiply the top by 3. 3 minus 2 is pi thirds. 210 degrees, so there's 90, 180, If I go some more, that's 210 degrees. So how much past 180 did I go? I'm going to go 210 minus 180. That is 30 degrees. So my reference angle, again, it goes back to the x-axis. So what is this part right here? That part is 30 degrees. So that's my reference angle. On part D, so negative 7 pi twelfths, just think of it this way, 6 pi twelfths, that's half, because 6 and 12 reduced to be pi halves. Pi halves is 90 degrees. So 7 pi twelfths is more than 90. So it's right here. Again, my reference angle, I draw it back to the x-axis. And so since a straight line is 180 degrees, I'm going to say, okay, I've gone 180 degrees, which is the same as pi, and I'm going to minus the 7 pi twelfths off of it to figure out what this piece is. So get common denominators. So 12 and 12. 12 minus 7 is 5 pi twelfths. Our reference angle will always be positive. Okay, so our reference angle is always positive. So 5 pi twelfths is my reference angle. Now negative 5 pi twelfths, that's less than 6 pi twelfths, which means it's less than 90. So that goes to right here. Okay, so if I draw my line right here for negative 5 pi twelfths, this is negative 5 pi twelfths. It's actually not right there. It's more like this. And I draw my reference angle, I draw my angle back to the x-axis. Well, that's just the same as it was. So it's just 5 pi twelfths. So we always just drop the negative on that right there and on this part, because our reference angle we always want positive. So that's 5 pi twelfths. So that was the answer to E. So notice the answer D and E for the reference angle is the same. But when we set these up, if we were doing the sine, cosine, tangent, this y would be negative and this x would both be negative. Whereas over here, the x would be positive and the y would be negative. Number 7, find the exact value for the following. When it says exact value, you're going to use your unit circle. So sine of 180. So I go to my, let's see, let's not do that. So I go to my unit circle. Here is 180 degrees. So the sine value, remember it goes cosine, sine. So my sine value is the second one. So the sine value at 180 degrees is 0. So this answer is 0. Cosine of 3 pi fourths. So I find 3 pi fourths. So there's 1. There's my 3 pi fourths. The cosine is the first one. So my cosine value is negative square roots of 2 over 2. So negative square roots of 2 over 2. Secant is opposite of cosine. So I'm going to find my cosine of 5 pi sixths first of all. So I go to the cosine of 5 pi sixths. So 5 pi sixths, that is this one. Cosine is the beginning. So that is negative square roots of 3 over 2. So this is negative square roots of 3 over 2. The secant of that, if I flip it upside down, is negative 2 over square roots of 3. I can't leave a square root on the bottom. I multiply top and bottom by the square roots of 3, so it's 2 square roots of 3 over 3, and then negative is in front. All right, tangent of 210. Remember, tangent is y over x, or sine over cosine. So I go to my unit circle. I'm looking for 210 degrees sine and cosine. So 210 degrees, there it is. So sine is negative 1/2. Cosine is the square root of the negative square root of 3 over 2. So negative 1/2. So negative 1/2 divided by negative square roots of 3 over 2. Dividing by a fraction is the same as multiplying by its reciprocal. So that's negative 1/2 times 2 over negative square roots of 3. The 2's cross cancel, the negative and negative go away. So I'm left with 1 over the square root of 3. We don't like to leave a square root on the bottom. So I multiply top and bottom by the square root of 3. And that leaves me with the square root of 3 over 3. Part E, the cosecant of 5 pi thirds. So that's the opposite of sine. So I'm going to find the sine of 5 pi thirds. So 5 pi thirds is right here. And the sine value is negative square root of 3 over 2. So remember, the sine's the second one. So it's negative square root of 3 over 2. So sine is negative square root of 3 over 2. For the cosecant, I flip that upside down, so it's 2. Negative out front, square root of 3. I can't leave a square root of 3 on the bottom, so I multiply top and bottom by the square root of 3. So it's negative 2 square roots of 3. On the bottom, the square root of 3 and square root of 3, since they're both square roots, it really makes the square root of 9. You multiply those together like this, so it's the square root of 9. But the square root of 9 is just 3. So that's why we say, in essence, that the square roots go away when you multiply them together. Number 8, what is the arc length of an arc with a radius of 7 and a central angle of 130? Remember, the formula is S equals R theta. That's the arc length. That's the S. R is the radius, so R is 7. The angle is 130, but it has to be in radians for this formula. So I multiply by pi and divide by 180. So I have 7 times 130, 7 times 130, times it by pi, and divide it by 180. So that gives me 15.88. If I round to the nearest tenth is this first one. So I look at the second 8, and that's bigger than 5, so it rounds that up to be 15.9. Whatever my units are, feet, centimeters, whatever. The next one, same question, but it has a radius of 10 and a central angle of 2 pi thirds. So S equals R theta. The radius is 10. Since this is already in radians, I don't have to convert it. I can just type that in. So 10 times 2 pi divided by 3. So that's 20.9. So 20.9. Number 10, a bicycle tire makes 10 revolutions per second. The tire has a radius of 16 inches. Find the angle in radians and degrees which the tire rotates in 1/30th of a second. So in 1/30th of a second, it makes 10 revolutions in 1 second. So 10 revolutions in 1 second equals x in 1/30th of a second. So if I multiply this, to get rid of a divide, you multiply, so I'm going to go 10 times 1/30th. I can cross cancel, that becomes 1, that becomes 3. So x equals 1/3 of a revolution. So remember, a full revolution is 360 degrees. So I'm going to go 1/3 of 360 degrees. So 360 divided by 3 is 120. 360 divided by 3. The reason you can do that in your head, if you go 36 divided by 3 is 12, and then just add a 0 onto it. So find the angle theta in radians and degrees. So there it is in degrees. If you look on your unit circle, 120 degrees is 2 pi thirds. Or you could convert it. 2 pi thirds. You could convert it by going 120 times pi divided by, by 180. All right, the next part says create a sine equation to model the path of a rock which is stuck in the tire tread in relation to the axle. So we're not going to do this in relation to time. We're just doing it in relation to the axle, okay? So what that means is, if I have my picture, then my tire goes round and round, right? At this point, in relation to the axle, it is 0 above. At this point, it is 1 above. At this point, it's actually not 1, it's actually 16 inches above. And at this point, it is 16 inches below. So when your resting point is on the x-axis, that's a sine wave. And I also tell you to use the sine equation. So f of theta, so our amplitude is 16. It goes up 16 and it goes down 16 below the axle. So that's our amplitude. 16 sine theta. And our midline is 0, so we have plus 0. If we were to do this in terms of time, it's a whole different problem. This does it in relation to the angle, and we'll leave it at that for now. Well, we'll go ahead and do the other two. So this is in relation, this is the angle. Now if I do time, okay, so the frequency on this is 10 revolutions per second. So the period is the reciprocal of that. Is 1 over 10 or 0.1 of a second. So that's how long it takes to go it takes 0.1, so or 1/10 of a second to go 1 revolution. So now that's the period. So we know the period is equal to 2 pi divided by b. So the period is 0.1. 2 pi divided by b. Since b is on the bottom, you can swap these places. So you have 2 pi divided by 0.1 equals b. 2 divided by 0.1 is 20. Okay, so that is what b equals. So now I can rewrite the equation. F of theta equals 16 times sine of 20 pi theta plus 0. So this is in relation to time. This one is in relation to the angle. So both equations are correct. They're just in different. So instead of, on this one, realistically, instead of a theta right here, I should use a t for time. And that would be the difference on them. All right, that was number 10. Number 11. Solve for the unknown values. So there's two ways to do these. The easiest way is to realize that this 6 is double the 3. So that's a 30, 60, 90 triangle. So B is 30, A is 60, and on a 30, 60, 90, it's x, 2x, and x times the square root of 3. In this case, x is 3, so A is 3 square roots of 3. You could also find the angle of B or A using your relationships. If I go from angle A, this is adjacent and this is the hypotenuse. So that's cosine, so I could say the cosine of angle A equals 3 over 6. So now I go to my calculator. Since I'm after an angle, I hit second cosine, 3 divided by 6, enter. And it tells me it's a 60-degree angle. And once I know that A is 60 degrees, I can go 180, minus 90, minus 60, and that gives me that B is 30. Same thing to find A. Once I know this angle is 60, I could have said A is the opposite of 60, so I could have said sine of 60 equals A over 6. And so then I would go 6 times the sine of 60. So I'd go 6 times the sine of 60. And it's 5.19, which is the same as 3 times the square root of 3. So notice those are the exact same things. On this one, on part B, the easiest way to do this problem is to remember if this is a 6, this is x, and this is x squared roots of 2 because it's a 45, 45, 90. So if ever you get one side is a 6 and then the hypotenuse is the same number, which is 6, with the square root of 2, that means it's a 45, 45, 90 degree triangle. So angle A is 45, angle B is 45, and side A is 6. Again, if you didn't remember how to do that from a 45, 45, 90, if I want to find angle A, this is the adjacent, this is the hypotenuse. So again, I go to my calculator, I'm after an angle, so I'd say cosine of my angle equals 6 over 6 square roots of 2. So I come to my calculator, I'm looking for an angle, so I go second cosine, 6 divided by, parentheses, 6 square roots of 2. Close my parenthesis. Let's see. Let's get out of the square root. Now close my parenthesis. And close that one. And it tells me that it is a 45 degree angle. And once you know that it's a 45 degree angle, you know that these two sides have to be the same because those are both 45s. Number 12, what is the formula for the law of sines? Little a over sine A equals little b over sine B equals little c over sine C. What is one of the formulas for the law of cosines? C squared equals A squared plus B squared minus 2AB cosine of C. Again, remember whatever you have here, C, A, or B, that's the angle that's going to be here. So if it's a C here, it's a C here. If it would have been an A at the beginning, you know it's going to be the cosine of A. And then it's just the other two, B squared and C squared minus 2BC. So there's all three options. You can choose any one of those. And this one you could have had it upside down. You could have had the sine of A over little a equals the sine of B over little b, and so forth. Number 14, given measure of angle A equals 25. So if you have a triangle, this is 25, this is 15. That's A, little a. We choose one of them as C. We'll call this C, that's 18. This is angle C, therefore. This is little b, this is angle B. We need to find all of the missing stuff. Because I know an angle and its opposite side, I can use the law of sines. So I'm going to find angle C. So I'm going to say sine of angle A over little a equals sine of angle C over little c. So sine of angle A, so sine of 25 over 15 equals the sine of C. I like to put my unknown on top. That's why I used the angle on top, because I know the side of C, but I didn't know the angle of C. So that's why I put sine of C on top, is because that's my unknown thing, my unknown quantity. So now to get rid of a divide by 18, I times by 18. So I'm going to put my calculator. I'm going to go sine of 25, times it by 18. So that's this times by 18 to get rid of that. And then I'm going to divide it by the 15. So sine of 25 times 18 divided by 15. And that's going to give me a decimal. But I'm after an angle. So remember, when you're after an angle, you have to use the inverse sign. That's the sign of the -1. Or they also call it the arc sign, A-R-C-S-I-N. So the first thing I'm going to do is I'm going to make sure I'm in degrees. So I come to my mode, I go 1, 2, 3 down, it's on degrees, so I'm good. So to get out of there, if I look above mode in blue letters, it says quit. So anything in blue letters, if I want to use it, I use the second button, because that's the blue one, so second quit. So now to get the angle, I'm going to go second sine of this. Now to get that answer, if I look above the little negative sign in blue letters, it says A and S, that's the answer. So if I hit second, that little negative button, it puts my answer from the previous problem in that spot. So my angle is 30.5. So now I can go 180 minus 30.5 minus my other angle. So we just found angle C is 30.5. So once I know two angles, if I know two angles, a triangle has 180, so I can go 180 minus those two. So that's what I started to do, 180 minus 30.5 minus 25. Enter. 124.5. So my unknown angle is 124.5. So now to find missing side B, I go little b over the sine of its angle, which is 124.5, equals either one of these relationships. So I'm just going to use A because it's highlighted. 15 over sine of 25. So now I'm going to go 15 times sine of 124.5 and divide it by sine of 25. So 15 times the sine of 124.5, and I'm going to close my parenthesis, divided by the sine of 25, because that was the divide right here. Close my parenthesis and hit enter. And it says my side is 29.3 because that's a 5. I round the tenths up. So little b is 25.3, or 29.3, sorry. All right. This one, given measure of angle C equals 75. So here's a triangle, beautiful triangle. Imagine that side straight. Across from angle A is 5, across from angle B is 7. So I have a side, an angle, and a side. I don't have any pair of given information. I don't have a side and its opposite angle anywhere. So that means I'm going to use the law of cosines. So C squared, I'm going to find this missing side C, equals A squared, which we called 5, and B squared, which we called 7. You could have called them opposite. You could have, you could have done something else, but the problem tells you. Minus 2 times 5 times 7, cosine of angle C, and angle C is 75. So now I just come to my calculator and I type that in. So I go 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of our angle, which was 75 degrees. Enter. Now that's what C squared equals. So C squared equals 55.88. So C squared equals 55.88. To get what just C is, I need to take this squared off. So to get rid of that squared, I square root it. So I come back to my calculator, I'm going to go second square root of this answer. So I go second negative little button, it puts the answer there, enter. 7.48 or 7.5, we'll just call it 7.5, we're down to the nearest tenth. So 7.5. No, it does not always work just to move a decimal in front of that angle. It just happened to be that way on this problem. So now I need to find another angle, but I know this opposite side is 7.5. So now I have a pair of information. I have a side with its opposite angle, so now I can use the law of sines. So I can say sine of angle A, because that's the one I'm going to try to find is A. I could have tried to find B. I just chose A because it's alphabetically first, I guess. Equals the sine of 75, because that's my known angle with its corresponding known side. So sine of 75 over 7.5. So now to get a sine of a alone, I need to multiply it by 5. So I go sine of 75 times it by 5 and divide it by 7.5, because remember the 7.5 is on the bottom right here. So divided by 7.5. Enter. And it gives me a decimal number. Again, we're after an angle. Remember, we're after angle A. So see here it says sine of A. Anytime you're after an angle, you're going to go arc sine or the second sine, whatever you want to remember it by. Sine to the -1, the inverse. Then I'm going to go second answer. So I'm going to take that decimal, plug it in, and hit enter. And that says it's 40.08 or 40.1 if I round to the nearest tenth. And that was angle A, so that's 40.1. So now I know 40.1 and 75. So I can just go 180, because that's how many degrees of a triangle, minus those two angles that I know. So 180 minus 75 minus 40.1. And that gives me 64.9. All right. We'll do this one. On this one, there's a little star by it, and then there's a whole bunch of side notes. We talked about this in some of our classes. Anytime you have an angle, so here's angle A, and then I know its opposite side is 13, or no, its opposite side is 9, sorry. This is 42, and we'll call B 13, so that makes this angle C. Anytime you have an angle followed by a side and a side, there's the possibility there could be two triangles. There's a way to find out if there are two triangles or not. Okay, here's the general rule that there's a whole bunch of rules that I wrote down on your paper, and it's all down on the right hand side of 16. But the first thing you have to do is figure out what H is. So H is equal to B, so the side that's not across from your angle. Then the sine of your angle. So I'm going to type that in my calculator to get what H is. So 13 times the sine of 42. 13 times the sine of 42. So H is 8.7. So H equals 8.7. So if I look at that, H is my smallest. So H is smaller than 9, which is my A, which is smaller than B. So if I look at my little rules, it says the first one, if H is less than A, less than B, there are two solutions. So that means I'm going to have two solutions. So we'll go through the normal process of doing this problem, and then I'll explain how you get those two solutions. All right, so here we go. We want to find side C, angle B, and angle C. I know that this is an angle with its opposite side, so I can use the law of sines to find angle B. So I'm going to say sine of 42 over 9 equals the sine of B over 13. So I'm going to go sine of 42 times it by 13 and divide it by 9. So sine of 42 times it by 13 and divide it by 9. So I times it by 13 and divided it by 9. Hit enter. Now I'm going to go second sine and the answer. And that gives me the angle is 75 degrees. So angle B is 75. The other possibility is go 180 minus 75, which is 105.